Good morning one and all. Myself Pushpa, working as an assistant professor in the Department of Pharmaceutical Analysis of Aditya Pharmacy College. So I am dealing with currently instrumental method of analysis subject in final year. So coming to this subject, instrumental method of analysis, in this subject we will learn about different type of analytical techniques which are used for the analysis of different substances, different drug components and other different metabolites. According to this subject, there are different types of analytical techniques based on the principle used. For example, different types of analytical techniques are spectroscopic techniques, in which interpretation of how much light is absorbed by the sample. Based on the how much light energy is absorbed, we can detect the compound. Those are called as spectroscopic techniques. In that there will be UV visible spectroscopy, IR spectroscopy, NMR spectroscopy, like that. And also the classical oldest methods like titrations. In those titrations, we will analyze or identify different types of chemical compounds based on the visual detection of color changes and also based on the precipitation or turbidity or color changes or colorless changes. So coming to the another analytical technique, which one we will use for the analysis is chromatographic techniques. At present we will go and discuss about that chromatographic techniques. So coming to this analytical technique, in this chromatography we are having so many sub techniques, which one we will discuss later. Coming to the first topic, that is history behind the chromatography technique. That means how the scientists have derived or invented this chromatographic technique. First of all, the Russian scientist named Michael Twist in the year 1903, when he was doing experiments on the color pigments like leaves, he isolated all the leaves from the plant and he extracted that isolated leaves and added to the petroleum ether or ethanol extract, and by taking one glass column like structure, he introduced all these leaf extracts which is moisturized or saturated with the petroleum ether, and he introduced into the glass column. So when he introduced it into the glass column, whatever the pigments which are present in that leaf extract, they started separating itself based on their distribution ratios. That means if those pigments which are present in that leaf extract are having more affinity with the solvent which is used, they will attract with the solvent, or if they are not having the affinity with the solvent which we are using in the glass column, they will elute later. So based on the distribution of the plant pigments which are present in the leaf extract, the distribution ratio or the color separation will be happen. You can see in this diagram. See, first of all, they have taken one glass column. In that glass column, they have filled this glass column with the calcium carbonate, that is chalk powder, and into this glass column which is filled with the calcium carbonate or chalk powder, they have introduced the leaf extract in which so many pigments are there, and that extract is saturated with the ethanol solution or petroleum ether solution, and they left it for some time. Based on the different distribution ratios of the pigments which are present in that leaf extract, they have formed different color bands. For example, you know, the plant pigments are of different colors: chlorophylls which are in green color, xanthophylls which are in yellow color, carotenoids which are in orange or red color, and anthocyanins which are orange in color. So these are the different types of color pigments. Whenever they have introduced those leaf extracts which are having different color pigments, they extracted in these different ratios based on their distribution. See, they got the green colored pigments fastly. So because they are having different distribution ratio, whereas the orange colored and red colored bands, they are not eluted faster. So based on the distribution ratio, these pigments are shown different types of color bands, and after the separation is happened in between all these pigments, they cutted this calcium carbonate or chalk powder which is having this color, color pigments. They separated or isolated these color bands by removing this chalk powder from this glass column, and they cutted those each separate color sections, and they isolated and they filtered the separate plant pigments. This is the process which is followed by the Russian scientist named Twist. So whenever he is doing this experiment, he isolated these all color pigments like chlorophylls, xanthophylls, carotenoids, and by doing this experiment he introduced the term chromatography. So this is called as chromatography. That's why based on this experiment he gave the name chromatography based on the color which is produced in that process. That's why chromatography means, chroma means color and graphene means writing. So after he done this experiment, he introduced the name called as chromatography based on the color produced. Okay, this is about the history of the chromatography which is introduced by the scientist Twist. Okay, so coming to the main definition of the chromatography, chromatography is defined as it is one of the method of separation in which whatever the components or whatever the drug substance which one we are going to separate, that substance should be distributed or introduced between two phases. Two phases means two separate phases, or separate solid or liquid or gas or liquid or liquid or liquid, any two separate phases. One is stationary phase and other one is mobile phase. That means whatever compound which one we are going to separate, that compound should be distributed or introduced between two phases. If the compound is having more affinity with the stationary phase, it will be with the stationary phase, like dissolves like that. If the component is more having affinity with the stationary phase, it will be with the stationary phase, and if the component is having more affinity with the mobile phase, it will move along with the mobile phase. In the name itself, it was denoting that stationary phase means it should be stationary, mobile phase means it is mobile, that means it is movable. So based on the compound which one we are going to separate, based on its affinity towards the stationary phase and mobile phase, the separation will be happen. So finally, the main definition of the chromatography is, it is a physical method of separation in which the component which one we are going to separate, it is distributed or introduced between the two different phases which are stationary phase and mobile phase. Okay, so before going to these chromatographic techniques, we have to know different technical terms. In all the subjects we are having different technical terms. For example, in biology, whenever we are reading, you have to know different technical terms regarding the medical terms. Like that, even in analysis also, especially in the chromatography techniques, we have to know, before going to the main theme, you have to know some chromatographic terms. What are those chromatographic terms? Now we will see. The chromatographic terms which one we have to by heart or you have to know before entering into the techniques are, first one, stationary phase. Already I told you, in this chromatography techniques, especially compulsory we have to use two phases. One phase is stationary phase and another phase is mobile phase. Coming to the stationary phase, which one we will also call it as adsorbent. Adsorbent means the substance on which anything will come and got adsorbed. It will not move, it will be stationary. On that stationary substance, something or anything which we are keeping, that will come and get absorbed. That's why the stationary phase here, it is also called as adsorbent. So the stationary phase which one we are using in the chromatography is either a liquid or a solid. That means we can use a solid stationary phase or a liquid stationary phase. So solid or liquid phase of chromatography system, on which the material or the substance which we are going to separate is adsorbed. That is called as stationary phase. Coming to the next one, mobile phase. It is also called as eluent. In the name itself, we are expressing it as a mobile phase. Mobile means movable. This phase is movable. So, and that too, the mobile phase, which one we are using is either liquid or gas. That means we can use gas mobile phase like helium, argon or hydrogen gas, and also we can use liquid mobile phases also. So this is the one of the phase of chromatographic system which will flow on the stationary phase and make the component which one we are going to separate to move along with it. Stationary phase means it will absorb the substance which is going to be separated. Mobile phase means it will make the substance which one we are going to separate to move along with it. That is the difference between the stationary phase and mobile phase. And coming to the another technical term of chromatography, that is adsorbate. Adsorbate means the mixture of components which, that means whatever the components which one we are going to separate, that mixture of components is called as adsorbate. And coming to the next technical term, analyte. Already you know. Obviously, whenever we are adding the mixture of components to the stationary phase or mobile phase, among that mixture of components, the sample which one we are isolating from that mixture is called as analyte. Understood? And the next technical term is eluate. Eluate means among that mixture of components, which one is going to separated or eluted along with the mobile phase. That means if that component or the sample or the analyte, if it is having more affinity with the mobile phase, it will go with the mobile phase. That means it will move along with the mobile phase. So that analyte or that compound which is moving along with the mobile phase is called as eluate. Okay. And the next technical term is elution. The process of moving of this analyte along with the mobile phase is called as elution, or you can also call it as development. That means elution means moving or developing. Whatever the sample which one we are going to separate, if it is having more affinity with the mobile phase, it will move along with the mobile phase. That process of eluting or moving is called as elution. And coming to the last technical term, retention factor. I already told you the sample will move along with the mobile phase. Based on the movement only we can detect which compound it is. So how much distance it is travelled. That distance if you are determining, then it is called as retention factor. That means how much distance the sample is travelled divided by how much distance the mobile phase or solvent is travelled. Already you know the mobile phase will travel to some time, because the mobile phase nature is moving. It will move how much it can move till the end of the glass column, but the sample based on its affinity towards the mobile phase it will move. So how much distance the sample is moved and divided by how much distance the solvent is moved, we have to calculate. For example, okay. So the distance travelled by the solute, that means the sample which one we are going to detect, divided by the distance travelled by the solvent is called as retention factor. Retention factor is nothing but whatever the compound we are separating, how much distance it is travelled. Based on that distance only we will detect the different samples or analytes present in that mixture. Okay, these are the different types of technical terms we have to learn before going into the main theme. And already we have completed what is the history regarding the chromatography, and also we have got the chromatography definition and also chromatographic techniques terms. And coming to the classification of chromatography, that means this chromatography technique is divided into different techniques based on different aspects. The chromatography is classified into 4 types based on different mechanisms. First one is based on the shape of the chromatographic bed. That means if you are using the paper for separation of the compounds, then it is called as planar chromatography or paper chromatography. Best examples are paper chromatography, TLC, HPTLC. Why these are coming in the planar chromatography means, here the shape of the chromatography system what you are using is in planar structure. That means we will use the paper, or we will use the aluminum sheet, or we will use the glass plate. all these plates which are in planar shape or rectangular shape or circular shape, those will come under the planar chromatography. The best example of the techniques which are coming under planar chromatography are paper chromatography, TLC, HPTLC, which we will discuss in the later classes. And coming to the next one, column chromatography. Column chromatography means here the shape of the chromatographic system which one we are using is in the form of column. That means it will be in cylindrical shape, like burettes. You know in our labs we will have the burettes which are in cylindrical shape or column shape. If we are using that type of structured columns, then it is called as column chromatography. In the previous one, we will use the rectangular planar shaped papers or glass plates. Whereas in column chromatography, we will use the cylindrical shaped glass columns. So the chromatographic techniques which will come under column chromatography are HPLC, UPLC, flash chromatography. Here we will use column shaped or cylindrical shaped chromatographic apparatus which are made up of either glass or aluminum or steel. This is the first type based on the shape. And coming to the next classification, based on the nature of stationary phase and mobile phase used. I already told you we have to use two phases, mobile phase and stationary phase. Based on the nature of mobile phase and stationary phase, the chromatographic techniques are divided into four types. That means if you are using gas mobile phase and solid stationary phase, then it is called as gas solid chromatography. That means in gas solid chromatography, mobile phase will be gas and the stationary phase will be solid. Coming to the gas liquid chromatography, GLC, here we will use the gas mobile phase and liquid stationary phase. And coming to solid liquid chromatography, stationary phase will be solid and mobile phase will be liquid. And coming to the liquid chromatography, here we will use both stationary phase and mobile phase as liquids. This is the another classification. Coming to the third classification, this classification is based on the principle of separation. That means on what mechanism the separation is taking place in the chromatography. Those are also two types: adsorption chromatography, partition chromatography. That means whatever the mixture of components which are mixing or which one we are adding in the chromatographic system, if in that compound, for example, if you are adding paracetamol tablet, you want to detect what are the different types of components which are present in the paracetamol drug. In paracetamol drug, there will be paracetamol, other excipients like binding agents, lubricating agents, preservatives, everything. So all the components which are present in that paracetamol compound mixture will not have same affinity towards the mobile phase and towards the stationary phase. Paracetamol may have the more affinity or more binding interaction with the stationary phase. So if it is having more affinity or binding interaction with the stationary phase, it will stay sometime with the stationary phase. If other excipients which are present in the paracetamol tablet like lubricating agent or preservative or binding agent, if they are more affinity with the mobile phase, means they will elute fast. If they are affinity with the stationary phase, means they will elute slow. So whatever in that paracetamol mixture, whatever the components which are present in that paracetamol mixture, if they are having more affinity with the stationary phase, it will elute slow, because stationary phase means it will not move. If the sample is having more affinity with the stationary phase, it will elute slow. If the component is having more affinity with the mobile phase, they will elute fast. That is the main mechanism which is happening in the adsorption chromatography. The other mechanism or other principle of separation is partition chromatography. Partition chromatography means here what will happen, the stationary phase or mobile phase, which one we are using, both are liquids. For example, oil and water. Oil and water means both will be immiscible, they will not mix with each other. When we are adding the another mixture or compound which we are going to separate into this oil and water, in that compound, for example, the components which are present in that compound, if they are having more solubility in the oil, means they will solubilize or they will mix with the oil. If the components which are present in that compound are having more solubility with the water, means they will go with the water. That means in partition chromatography, the main principle of separation is solubility. Understood? Whereas in the adsorption chromatography, the main principle of separation is affinity or binding interaction. Which is having more binding interaction? With the stationary phase, it will be with stationary phase. If it is having more affinity with the mobile phase, it will be with mobile phase. Whereas in partition chromatography, which is having more solubility with the mobile phase, it will move with mobile phase. Which is having more solubility with the stationary phase, it will be with the stationary phase. That means here the main principle is based on the solubility of the components, the partitioning of the component into the oil or into the water will takes place. Understood? This is the main mechanism in partition chromatography. Next, last classification is based on modes of chromatography. Till now we have seen the three classifications. The last classification is based on modes of chromatography. It will be advanced type of chromatography. Based on the modes of chromatography, it is divided into two types. Chromatography techniques are divided into two types. One is normal phase chromatography and another one is reverse phase chromatography. In normal phase chromatography, whatever stationary phases we are using, those are in polar nature. That means I already told you stationary phases we can use solid or liquid, but those solid or liquids also we have to use the polar compounds. Polar means which are having more OH groups, for example ethanol, methanol, water, like that. If we are using polar natured solvents and non-polar natured mobile phases for the separation of compounds, then it is called as normal phase chromatography. And coming to the reverse phase chromatography, here we will use polar natured mobile phases and non-polar natured stationary phases. Polar nature mobile phases means which are having more amount of OH groups. Non-polar nature stationary phases means which are having more amount of CH skeletal structure. Okay, these are the different types of chromatographic techniques based on different mechanisms. Okay, thank you.